All right, we got applying exponents 4.6. Here we go. First thing. Okay, to multiply powers with the same base, add the exponents. Your algebraic representation, use some type of a variable in this one. When they're talking about algebraic representation, they mean, let's do n to the, let's do a multiplied by n to the b. Product of powers, if we multiply like bases, you add the exponents, n to the a plus b. Then, quotient of powers. So if we divide like bases, subtract the exponents. So you got n to the a over n to the b, or n to the a divided by n to the b, however it would be written. N to the a minus b. Power of a power. Multiply the exponents. N to the a to the b. N to the a times b. We should highlight here the important information. You multiply, add the exponents, divide, subtract the exponents. Power of a power, multiply. Now we got a power of product. If you got a power of product, you apply that exponent into both. So you got n m to the a. That's going to give us n to the a times m to the a. This has a multiplying in the middle between the two. It's a power of a product. That means there has to be multiplying. It cannot work with adding. So do not confuse with n plus m to the a. That does not, you cannot bring in the exponents if there's adding or subtracting in the middle. It has to be multiplying, or as we'll see with the next one, dividing. So this does not equal n to the a plus m to the a. And lots of people try to do that. And a lot of you tried to do that in your last chapter when we were expanding. And you say, hey, I'm just going to bring the squared in and put it to both. That only works if it's multiplying. So let's put a big X through that. Do not do that. If you've got power of a quotient, again, apply that exponent in. So this would be n over m to the a, n to the a over m to the a. Okay, so take a couple minutes, pause here, go through, try to plug those in, see what you come up with, and then check and see if you get the same as what we do. Let's do this. Now that you've had a chance to work it through on your own and you've talked, let's see a couple different strategies. I will do it two different ways. Number one, I'm just going to plug it straight in and then slowly work my way from inside, working my way out. So wherever I see an a, put a -3. When you substitute, always substitute with brackets. So -3 to the 6 times 2 to the 9 over -3 to the 5, 2 to the 8 to the -2. Start there. Then, from here, okay, what I will recommend is you deal with the negative exponent on the outside then first. We'll deal with that right now. Flip the whole fraction. So -3 to the 5, 2 to the 8, -3 to the 6, 2 to the 9. Did anybody here make that their first move? Yeah, some of you. Does it have to be? No. There's lots of different orders that could be done on this. From here, I'm going to take these and say, oh, these are like bases. I'm going to subtract the exponents. Sure. -3 to the 5 minus 6 and 2 to the 8 minus 9 squared. Could you have just punched it into your calculator and went negative 3 to the 5 times 2 to the 8, get a big number, and then get a big number in the denominator? Absolutely. That would have worked perfectly fine. But we're going to try to use a little bit of strategy here. Subtract those exponents. So we've got negative 3 to the negative 1 times 2 to the negative 1 squared. You got a negative exponent. Let's take those down. That would mean 1 over negative 3. I'm going to keep that in brackets right now. And I've got 1 over 2 squared. Let's multiply those together. I got 1 over negative 3. That's negative 1/3 times 1 over 2. 1 over negative 6 squared. Or negative 1 over 6 squared. From here, square the numerator, square the denominator. Apply that squared to both. Now, this, what I've written, is not correct. What have I done wrong here? Forgot the brackets. Right now I'm saying 6 is only squared. I need it to be negative 6 being squared. You've got to have the brackets. This is meaning 1 squared is 1. Negative 6 squared, 36. Didn't touch a calculator, so we want to be able to use some strategies so we don't have to get these big, huge numbers that we're not really sure what to do with. Use your strategies. Could we have reduced it before we even plugged it in? Absolutely. We could have taken it right from the beginning, done all of our work with the A's and the B's, simplified, and then from there, plug in the value of negative 3 and 2. We'll move on. I think I discussed a bunch of different ways you could have done it. Hopefully you compared. Hopefully you saw that there's different ways and different orders that you can do exponents. That's going to happen every single time. So the way I'm going to do it might not be the way that you approach it, but I'll give you some strategies that I think work that have the least number of errors. Looking at A. First thing, deal with that negative exponent on the outside. It really helps because otherwise people tend to forget it. So we're going to deal with that negative that's out there. Flip the fraction, 4x squared y to the 6 over 2x cubed y squared to the positive 3. Now from here, let's simplify within. So deal with the negative exponent outside first, then simplify inside, and deal with it as 3 totally different fractions. We've got 4 over 2. Take that down to lowest terms. 4 over 2, I can divide both of them by a 2. That's going to give me a 2. That's going to give me a 1. So we hi-ya those guys right there. From there, we've got the x squared over an x cubed. Start writing this. Now, I don't need to have the 1 at the bottom. I'm just putting it there as a placeholder so we don't forget that we did that at the moment. You could leave that 1 completely off. Divided by 1 doesn't do anything really for us. Now we're going to subtract the exponents. Don't write this just yet because I'm going to show you a couple things. Thing 1, I could do this. X to the 2 minus 3. If I do x to the 2 minus 3 and I bring that 3 up, will that give me a positive or negative exponent? Negative. I want to have positive exponents at the end. We don't like to leave things with a negative exponent. So because of that, I could subtract in either direction. Either I can bring the 3 up and go 3 minus 2, or I can bring the 2 down and bring it down here and say 3 minus 2. We want to try to do the order that's going to give us the positive exponent. Both of them will work. If you do what I did in purple, that just means that at the end, you're going to have to then take it to the denominator. Not a big deal. I'm not going to do it. I'm just going to take it straight now to which direction I can see will make it positive. Which way do I want to move? Do I want to move the y this down or the y up? Up. If I move it up, then it'll be 6 minus 2. That'll be a positive number. If I move it down, I'd have 2 minus 6, which would be a negative number. So the one you're moving is the one you're subtracting. The one that stays goes first. So I'm going to move it up. So I have y. The 6 is in the numerator already. It stays 6. The one that moves is the one that you subtract. 6 minus 2 cubed. Now I know a lot of you can do that subtracting in your head, and I'm totally fine with that. I need to show what we're doing here, though. So we got 2y to the 4 over x to the 1. I'm going to put the 1 there just so you know I didn't forget about it. Cubed. Now we apply that cube to all parts. Whoa. Losing my mic here. Woo. Math's just going crazy. I have to apply this 3. There's no adding and subtracting, so we're good here. That 3 has to apply to the 2, to the y, and to the x. I'm going to write those out. We've got 2 to the 3, y to the 4 to the 3, x to the 3. Do each of them separately. 2 to the 3. That's 2 times 2 times 2. We actually do 2 to the 3. When it's a number, just go straight up and use the exponent. 2 times 2 times 2, 8. Y to the 4 to the 2. What do we do with those exponents? Multiply. Y to the 12 over x to the 1 to the 3, x cubed. Last moment check. Do I have any negative exponents? No. It's good. It stops there. If I have some negative exponents, I deal with those and I flip it to the other side. A negative number, like if this was negative 8 in front, that would have been totally fine. A negative number is okay, negative exponent not. Let's try the next one. Multiplying the 2 together. We are going to just bring them, I'm going to multiply in any order. There's no adding, subtracting. It's just multiply, 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 all the way across. So really I've got 3 times 15, and then a cubed times a squared, and b to the negative 2 times b to the 5. You don't need to rearrange these. I just need to show you what we're actually doing. 3 times 5. 45. A cubed times a squared. A to the 5. We add the exponents. A to the 5. B to the negative 2 and b to the 5. B to the 3. We add the exponents. Negative 2 plus 5. Add the exponents. B cubed. Now, do I have any negative exponents? No. Can I combine anything else together? No, we're done. That's finished. Now we bring in some numbers. But we want to use our strategies first as we carry through this. Whew, here we go. Deal with this garbage first. At the same time, we can deal with that garbage. Then we'll divide them once we get it cleaned up a little bit. Exponent of exponent, we multiply those together. So -4/5, keep it in brackets, to the exponent of -6. Divided by -4/5. 4 times -5, -20. Now, you got a negative exponent here. Should we flip it? I would say no, don't do it. Here's the reason why you don't want to flip that negative exponent right now. Because as it's sitting, you've got the same bases. We're dividing, we could subtract those exponents straight now. If we start flipping, then we're like, oh, we might not have exactly the same. So, let's combine them straight up right now. -4/5, -6. If we're dividing, subtract the next exponent. So we got -6 minus -20. Wait a minute. Subtracting is the same as adding the opposite. Let's do that adding the opposite bit. -6 plus 20 now. -6 plus 20 gives us positive 14 on this one. Do we have a positive exponent? Yes. That's a good thing. Is my answer going to be positive or negative at the end? I've got a -4/5. Why would it be positive? Nice. So let's write that down. Answer will be positive. I don't want to take it down and get to the big, huge number, but answer will be positive because the exponent is even. If it was an odd exponent, we'd have -4/5 times -4/5, which is positive, times a -4/5, which is negative. The evens will make it positive. You have an even number of negatives. The odd exponent would make it negative. Okay. Fractional exponents. We've got dividing and multiplying. If you're multiplying and dividing like bases, that means you're adding and subtracting exponents, and those exponents are fractions. You get to add and subtract fractions. Lucky you. Because I know you're so lucky, I want you to try this one yourself first. All right, let's try this out here. We've got like bases all the way through. So let's start with our numerator. 9 to the 5/4. We're multiplying like bases, so add the exponents. (5/4) plus -1/4 gives us 9 to the 4/4. 4/4 is just 1. If you wanted to just change it to 9 to the 1, great, go ahead. I'm not. Here's the reason. I look ahead and say, ooh, the denominator also has a fraction that's over 4. I'm just going to keep it as such. But yes, you could have went to 9 to the 1 if you wanted to. I'm not going to. Now we're dividing like bases. Subtract the exponents. Just makes this step a little bit easier. 4/4 minus 3/4 gives us 1/4. The instructions were to a single exponent. I don't have to evaluate. Done deal. Give yourself a pat on the back if you got that one right. Now we're multiplying. I don't need to put them beside each other. I can just say I'm going to do the m's together, and then I'm going to do the n's together. Multiplying like bases, add the exponents. Multiplying like bases, add the exponents. 4 plus 2, 6. Negative 2 plus 3 to the 1. Don't need to put the 1. You can just leave it as m to the 6n. Treat these as 3 completely separate fractions. You've got your 6 over 14. You've got your x's, and you've got your y's. 3 completely different fractions. The 6 over the 14, what can I divide the 6 and the 14 by? 2. That's the most I can do. So I'm going to high out right from here. Gives me 3. High out gives me 7. I'll write those ones in there. Then I've got my x's. Do I want to bring the x's up to the numerator or down to the denominator? Which way is going to make it positive? Up, because I have a positive 4 up on the numerator. So I got x 4 minus 1. If you went the other way, not a big deal. You would just have a negative exponent at the end to deal with. Not a problem. The y's. Which way is going to make it positive? Bringing the 2 up or the negative 3 down? Minus a negative. So we're going to subtract a negative, which we can say, oh, that's going to plan ahead, is going to go 2, the 2 stays, minus a negative 3, adding the opposite. One of the directions has to make it positive. And if you pick the wrong direction, not a big deal. You just have a negative exponent that you flip to the other side and make it positive. X to the 3 over 7, y to the 2 plus the 3, 5. Can't go any further. Done. Had you gone this way instead, had you said the y to the negative 3 minus 2, let's just say you went that direction, is not a problem. You would have just said x to the 3, y to the negative 5. Oh, I still have a negative exponent. Take that negative 5 to the denominator and make it positive. So it doesn't really matter which direction you go. Positive exponents at the end. Whew. Apply that 3/2 into all the parts. 25 A's and B's. 3 different parts. Apply it to all 3. Now, some of you can do all of this part in your head, and that's okay. I'm going to show all the steps. 25 to the 3/2. Don't punch it into your calculator. Use your strategies. What does a half exponent actually mean? Square root. So I've got the square root of 25 cubed. I'm just going to continue with that. 25, square root of 25? 5. So I got 5 cubed. 5 cubed? 125. All right. I've gone through and I've brought the number all the way down. Then I've got a to the 4 to the 3/2. 4 times 3/2. Sure, it is 12 over 2. 12 over 2 goes down to 6 over 1, so it's a 6. Let's look at some strategies to be able to keep your numbers smaller. When you're multiplying fractions, you can go across to the other one. 4 divided by 2. Hiya. 2 times 3, 6. Either which way, we got 6. This is a to the 6. Now we've got b to the 2 to the 3 over 2. That means multiply the exponents. 2 times 3 over 2. Yeah, you could go 2 times 3 is 6. 6 divided by 2, 3. But I could divide 2 divided by 2. Hiya goes to 1. And I'm left with 3. B to the 3. So we've got 125, a to the 6, b cubed as our final answer. Let me write it up over here so you can see it easier. Oh no, now we got some big things going on. Step number 1, deal with, when you got a fraction and an exponent on the outside, deal with a negative fraction on the negative exponent on the outside first. Do I have a negative exponent? No, so I don't have to worry about that, step 1. Step 2, simplify within the fraction. So I've got 3 different parts. The numbers, the x's, the y's. 50 divided by 2. 25. 25 over 1, but I'm just going to keep it 25. Then we got x squared and x to the 4. Which way is going to make it positive? Bring it down. X to the 4 minus 2. The y, do I take the y up or down? Down. It's going to keep it positive. Y to the 7 minus 4. Brackets to the 1/2. From there, 25 over x to the 4 minus 2, y to the 7 minus 4, 3 to the 1/2. We're going to bring that exponent into all 3 parts now. Apply it in. We got 25 to the 1/2. We've got x squared to the 1/2. We've got y cubed to the 1/2. 1/2 again means square root. If you have a number, take the square root of it. If you have a variable, just work with the exponents. So we got square root of 25 over. Multiply the exponents. 2 times 1/2. And y to the 3 times 1/2. Don't need to show me that step if you can actually multiply in your head. Square root of 25, 5. 2 times 1/2, 1. 3 times 1/2. Don't say 1.5. 3 over 2, thank you. Any negative exponents? No. Done deal. All right, last one. Problem solving, everyone's favorite. A cone with a height and radius equal. Ooh, that's important. Has this as its volume. What is the radius and the height of the cone to the nearest tenth of a centimeter? Notice what it says, nearest tenth of a centimeter. You actually get to plug it into your calculator and take it to a decimal. You don't need exact form. Let's plug in what we know. We know this, that h and r are the same thing. So I could either, wherever I see an h, put the r, or wherever I see an r, put an h. Which one would you prefer? Do you like R's better or H is better? R's better? I agree. It's like piratey. So we're going to go through 1/3 pi r squared times r. The H is the same as the R. The volume, I know what that is. They told me that the volume was 18. So wherever I see a V, I put 18. Let's clean it up a little bit. I got an r squared and an r. R squared times r is going to give me r cubed. Now we start using our algebra and isolating the r by itself. Let's deal this 1/3 first. If you're multiplying by 1/3, we could divide by 1/3. Dividing by 1/3, dividing by 1/3 is the same as, you got it, multiplying by the reciprocal. So right off the bat, we could have said, instead of, whenever you have fractions, don't divide by a fraction. Multiply by its reciprocal. 18 times 3 gives me what? $54, thank you. From here, we are multiplying by a pi. Divide by the pi. That cancels it off here. I don't want to punch 54 over pi in yet, because I want to do it all in one shot. That way I don't get messed up with what I've got for decimals. Right now we've got r cubed equals 54 divided by pi. I need to get r by itself. It's r cubed. What do I do? Cube root. Awesome. Let's cube root both sides of this. Cubing and cube rooting cancel each other off. Boom. We get left with r equals the cube root, I'll write it, 54 over pi. This right here is the exact form. It's got its root. It's got its fraction. Now we can punch that into the calculator. Cube root, 54 divided by pi. Use the pi button, please. Never 3.14, always the pi button. Okay, so we got 2.58 something, dot, dot, dot. This is, the dot, dot, dot tells me that there's numbers coming after, but I just go r with a dot above means approximately equal to, rounded to the nearest tenth, 2.6 units, centimeters. And a written question should have a written answer. The radius is 2.6, but what about the height? It's also 2.6. The radius and height are 2.6 centimeters. Done deal. Woohoo! There's the questions to work on. Let's do it.